Solving absolute value equations when we're only on a number line. We're on page 11 in your Springboard book, so you can be taking notes in your Springboard book or in your journal. This math tip is very important because it explains this step number 2 right here. It says by the geometric interpretation of the absolute value, that is a distance. And when we have simply the absolute value of x or a variable, we're talking about the distance from 0. So when you see this statement, like you see right here, the absolute value of x is equal to 5, we're talking about being at 0 on the number line. Okay, here's 0. And then we're saying that there are two numbers that are a distance of 5 away from 0. And those two numbers are positive 5 because 5 units to the right of 0 is the positive 5, but 5 units to the left of 0 is going to be the number negative 5. So because right here they're defining the absolute value to be the distance something is from 0, that's why we have two numbers, because you can move two directions on the number line. You can move to the right or you can move to the left. That is why we are going to use this step number 2, while we're going to end up with two equations to solve, because one of the equations is going to be for our movement to the right, and the other equation is going to be for the movement if we go left. Now, step number 1 says isolate the absolute value expression, because this expression right here, this equation, doesn't really make a lot of sense to us mathematically, and that is simply because it's not solved for the absolute value. So with all of these other things on there, we're going to learn later that those are transformations. What we need to do before we can make sense or interpret this equation right here is to isolate the absolute value bars. So that means get rid of anything that's on the outside by doing the opposite. So what's on the outside? We do minus 5. What's on the outside? It's times 2. So how do you undo minus 5? You add 5. They did not show their work right here, but we can show it right here. We'd add 5 on this side, so we have to add 5 on this side. That's where they got just that 2 times the absolute value of x minus 1 equals 6. Those two added to 0, those two added to 6. Then, of course, we would divide this side by 2, divide this side by 2. That got rid of that 2. So now we have the absolute value of x minus 1 is equal to 3. Now what this means, now that we have it isolated, we understand that we're going to be on the number line. The problem is we don't know where we are on the number line, because that's not just x. If it was just x, we would know we were at 0. But this has moved us off of 0. So we don't know where we are. We're somewhere. But I'm going to move 3 units to the right, and I'm going to move 3 units to the left, and I'm going to find out where I ended up. That's what we're doing right here. That's why step number 2 says write and solve. I really make this be step number 2. I say step number 2 is split the equations, and then step number 3 is solve the two equations. And then there's also step number 4 down here, which is check. Okay, so once we split the equations, and they have it split right here, it doesn't really matter. I usually like to write. Sorry, I'm not moving my little yellow circle. I usually like to write the equation that has the negative number on the left, just because it makes sense to me that we're moving to the left. And I usually like to write the equation with the positive 3 on the right hand side, because that indicates that I moved to the right. And then, of course, how did they get the 4 and the negative 2? Here they solved this one by adding 1 to both sides. 3 plus 1 is 4. How did they get the negative 2? They added 1 to both sides. And negative 3 plus 1 is negative 2. So those two numbers that we talked about up here are negative 2 and 4. And you can see them, they've got them plotted down here, negative 2 and 4. So that means that we were starting where? We were starting right here at 1. They don't really ask us that, but we can see now that if you start at 1 and you go 3 units to the right, you'll end up at 4. And if you start at 1 and then go 3 units to the left, you will end up at -2. That's what this absolute value equation is asking you to find. The starting place, and then where do you end up if you move 3 units to the right, and where do you end up if you move 3 units to the left. That's what solving an absolute value equation does. So I'm still on page 11. I'm going to do the try these part A down here. I wrote the steps down a little bit differently than what they had them written down up here. They had just 2 steps. I have 4 steps: isolate, split, solve, and check. They had the same thing. They just had split and solve in 1 step. So I just separated it into 2. So step number 1 says isolate the absolute value bars. Well, in this problem, the absolute value bars are isolated. So I don't actually have to do anything, but I am going to rewrite the problem. Step number 2 is split. When I split this problem, I remove the absolute value bars. That's the purpose of splitting it, so I can write this without the absolute value bars. So I'm going to write x minus 2, notice no bars. I'm going to put is equal to -3. That's because I'm going to move 2 directions. Remember, I'm going to move to the left, -3, and then I'm going to move to the right, +3. So one equation has got to be set equal to -3, and the other equation, or I think it's actually the word or, x minus 2 without the absolute value bars is going to be equal to +3. This means I'm going to move to the left or I'm going to move to the right. Now that's step number 2. I've split them. Step number 3 is solve each one. How do I solve this one? Do the opposite. Add 2 to both sides, and that gives me x is equal to -3 plus 2. That's -1. How do I solve this one? Do the opposite. Add 2 to both sides. X is equal to 5. So my the end point of my 2 points, or after I've traveled 3 units to the left and 3 units to the right, I end up at -1. So I put a dot right there, and I end up at +5, and I put a dot right there. And now, of course, you should be able to move 3 units and see that that's where I moved from. So 2, if I move 3 units to the right, I'm going to end up at 5. If I move 3 units to the left, I'm going to end up at -1. So 2 is where I started. They didn't really ask me where I started, but they want me to tell them where I ended up. I ended up at -1 and 5 after moving 3 units to the left, and then after moving 3 units to the left, and then moving 3 units to the right. You can then use your graph as a graphical representation to check your work, but you can also have an algebraic check. So the algebraic check would be to take the 2 answers that you get, and you got it. What are we going to do? We're going to plug and chug. So anytime you have to check something algebraically, that's usually what you do, is plug and chug. So you're going to take this equation, the absolute value. We're not going to put the x in there, because what are we going to put in its place? You guessed it. We're going to put in the -1. So if you do -1 minus 2, you get a -3. And then, of course, you take the absolute value of -3. You end up with a statement that says 3 equals 3, which is true. If you're typing this in the calculator, you type it in exactly the way I have it written down. The calculator will tell you if it's true or false. That's not the only one that we have to check. This one checked. We also need to plug in this one. So again, you're going to write down the absolute value, leave a space where the x is, put the -2. Okay, we wrote down the equation as it was given. We just left the x out, and you got it. What's going to go in the place of the x? This time it's going to be a 5. And if we say 5 minus 2, we get 3. The absolute value of 3 is 3. And again, we get another true statement. 3 is equal to 3.